Hi guys, today we're looking at why do ionic compounds only conduct electricity when molten or in solution. This is an important concept you have to understand, and it's found in all the different exam boards. Let's get down to it. So, what does molten mean? Molten means melted. What does solution mean? Solution means dissolved in water. Ionic compounds won't conduct when solid. Let's have a look experimentally at this, and then we'll go through the theory. So, okay guys, got in a bit closer there so you can actually see what's going on. What you can see here is I have a battery with 3 cells inside it. So 1.5 volts each. So guess how many volts in this series circuit? 4.5 volts. You add them all together in series, the battery. Now I'm going to connect this, and as you can see, when I make this simple series circuit with a battery and a light bulb, the light comes on. This proves that current is flowing around the circuit. Okay. Join these together and my light bulb comes on. So I've got a circuit. What I want to show you is that if I take an ionic compound, and I will quickly grab my salt, as one has, salt just lying around. So let's take some salt and pile it here. Hello, salt, are you there? Okay, a nice pile of salt. Does anyone know the name of this ionic compound? It's sodium chloride. Now, salt does not conduct electricity when solid. You can see here, yeah, we've got no conduction. The light bulb is not coming on. And what I have here, I've connected the 2 wires into the salt, and there is no connection. So we have no current flowing through. Why is that? Well, we're going to find out why solid sodium chloride will not conduct electricity. But first, let's show you what happens when we dissolve this salt into a solution. So, ta-da! I have some water here. Let's pour this lovely salt into the water and give it a stir to make sure that it dissolves. So we're going to stir that salt with my teaspoon, and we're going to make sure that that salt dissolves into the water. Let's give it a good stir. And what we're going to find is that once that salt has dissolved, this light bulb, as you can see there, the light bulb is coming on. And as this dissolves better, get my big fat hand out the way, you can see that what I have going on here, that connection any good? I've got conduction, but my hand is in the way, which is a bit annoying. So let's try that again. Take them out, put them in, light on, coming on. And again, yay, nice conduction. I use electrodes, but I decided to just do this roughly. Right, let's take this away and explain why sodium chloride or any other ionic compound conducts when in solution, and why doesn't it conduct when solid? If I haven't completely soaked the paper. Yes. Right, let's get down to it. Let's explain. Okay, guys, what we're going to do now is explain why did the salt solution conduct and why did the solid salt not conduct? Remember, salt is an ionic compound. So we have here a diagram that you should become familiar with. Ionic compounds form giant ionic lattices. What does that mean? Well, if we look at our sodium chloride never exists as a molecule like this. You cannot get one molecule of sodium chloride. That is simply, when we write NaCl, it's the ratio of the atoms within the giant compound that it forms. What do I mean by that? 1 grain of salt, so 1 tiny grain of salt, and I've got quite a few grains on my hand, is made up of trillions of those sodium chloride connections or ionic bonds. And these will never exist on their own like this, like you'd get with a covalent simple molecule like carbon dioxide or oxygen. These always exist in giant ionic structures. And the problem with a giant ionic structure is along comes some lovely electricity, and the lovely electricity wants to get through, and it can't do. Why can't it do? Because the ions are locked in a rigid structure. The charge or electricity cannot flow through. So we can call this charge, or we can call this current, and it cannot get through. However, let's say we melt it. So we go, let's go molten. And what happens when you melt something is energy is put in from the heat, and it breaks the strong electrostatic forces between the ions and allows them to freely move. Let's see what happens when electricity now attempts to flow through. Look, the electricity or the current or charge can now flow through the structure. So when we have ions that are free to move, current or charge can flow. What about if we dissolve in solution in water? So if we put ionic compounds in a solution, what happens is water molecules is very similar to melting, as in the ions are free to move. And why is that? Well, water molecules have disrupted the electrostatic forces, and these rubbish blue circles are my water molecules, and they have disrupted the electrostatic forces between the ions and allowed the ions to be free to move. And once again, our electricity, which we call charge or current in this situation, can flow through the structure. So when an ionic compound is in its solid giant lattice, current cannot flow through. When it is molten, which means melted with heat, current can flow through, or when it's dissolved in solution, current can flow through. Hence why our light bulb lit up when I dissolved the salt in water, and why the light bulb wouldn't light up when I just had solid salt. Now, if you're in an exam, are you expected to describe this whole thing? No, it's generally a 2-mark question, and the answer to this is it's a really simple answer. So we are going to put that down here, and here is the answer. When molten or in solution, the ions are free to move. In both situations, the ions are free to move, and we say, so charge can flow. So you're really looking at the 2 marks. 1 mark for here, 1 mark for here. So this is a really common question. It comes up lots of the time in combined science, in separate science, and it's basically, why did the sodium chloride conduct electricity when dissolved in water? Or why did the magnesium oxide conduct electricity when molten? And your answer is the ions are free to move, so charge can flow. You could also be asked, why did the sodium chloride not conduct electricity? So why did it not conduct electricity when solid? And of course we can answer, the ions are not free to move, so charge cannot flow. When we say, let's get to the marks, if I am making my flashcard or my revision card to answer this question here, that's all you need to know. Solution. And there's more, this whole topic here, which is part of structure and bonding, also crosses over into electrolysis, and we'll cover that in another video. So remember guys, hit the like, subscribe. There's plenty more videos coming that are there to help you get through your exams. So let's get to the marks.